Hello everyone. In this presentation, we are going to discuss about the parameters required for concrete mix design according to IS 10262-2019. Before preparing a concrete mix, we must collect all the necessary design information and material properties. A properly designed concrete mix ensures that the concrete achieves the required strength, durability, and workability with economical. According to IS 10262, the required information is divided into two groups: design stipulations and test data of materials. Under design stipulations, we need grade designation and target strength, type of cement and aggregate, exposure conditions, workability requirement, minimum and maximum cement content and maximum water cement ratio, requirement of admixtures, placing and curing conditions for concrete. Under test data of materials, we need specific gravity of cement and aggregates, water absorption of aggregates, free surface moisture content, sieve analysis or grading details, specific gravity of admixtures to be used. Let us discuss each parameter one by one. The first is the grade designation and target strength. The grade of concrete such as M20, M25 or M30 represents the characteristic compressive strength of concrete at 28 days. However, during mix design, we do not design only for the characteristic strength, we calculate the target mean strength, which is obtained by adding a safety margin to the characteristic strength using standard deviation, which is F-CK is equal to FCK plus 1.65 into S, where S is the standard deviation. It is taken from the site records of similar grade and materials. Where no such data is available, then we can refer IS 10262 table 2 for the standard deviation. This ensures that most concrete produced on the site achieves at least the specified characteristic strength. So this table gives the grade assumed standard deviation. For M10 to M15 grade concrete, it is 3.5. For M20 to M25 grade concrete, it is 4. And from M30 to M55 grade concrete, the standard deviation is actually 5. The second parameter is the type of cement. The cement used may be ordinary Portland cement, OPC, Portland Pozzolana cement, PPC, or Portland slag cement, which is PSC, depending on project requirements. The specific gravity of cement and its strength characteristics are important because they directly influence the volume calculations during mix proportioning. The third parameter is the aggregate properties. Aggregate occupies nearly 70 to 80% of the concrete volume. Therefore, its characteristics greatly affect concrete performance. We must determine the type of aggregate, whether it is angular or rounded, the maximum nominal size, grading zone of fine aggregate, and the combined grading of fine and coarse aggregates. Well-graded aggregates reduce water demand and improve concrete strength and economy. So here this table gives the parameters and what is fixed for the parameter. In case of type of aggregate, it may be crushed angular, subangular, gravel, a rounded or a blend, affects water demand. Maximum nominal size may be 10 mm, 12.5 mm, 20 or 40 mm based on member thickness and reinforcement spacing. Grading zone, zone 1 to zone 4 as per IS code from sieve analysis. And combined grading, coarse and fine aggregate proportion to satisfy the overall grading limits. The next parameter is the water cement ratio and cement content. Water cement ratio is one of the most important factors controlling both strength and durability. IS 456 specifies the maximum water cement ratio and minimum cement content for different exposure conditions. During mix design, whichever requirement is more stringent between strength and durability is adapted. Also, maximum cement content is generally limited to 450 kilograms per cubic meter to avoid excessive heat generation and shrinkage. The minimum cement content falls between 300 to 360 kg per meter cube, and it rises with exposure severity. And maximum free water cement ratio is between 0.4 to 0.55. It falls with exposure severity, and we can refer IS 456 2000 table number 5. It gives values depend on exposure category between mild to extreme. The next parameter is workability. Workability indicates how easily concrete can be mixed, transported, placed, and compacted. It is commonly measured by the slump test. Different construction situations require different slump values. For example, manually placed concrete may require a lower slump, while pumped concrete requires a much higher slump. Workability also affects the water content selected for the first trial mix. Here this table gives the slump value for different placing conditions, various placing conditions. For blinding concrete, shallow sections, hand placed, the slump value may be between 25 mm to 75 mm. And for normal RCC, manually placed, and for lightly reinforced sections, it may be between 50 to 100. For heavily reinforced sections and machine placed concrete, it is between 75 to 100. For pumped or tremmy concrete, it is between 100 to 180 mm. So the next parameter includes admixtures and other site stipulations. Chemical admixtures such as plasticizers, superplasticizers, retarders, and accelerators are used to improve concrete properties. Mineral admixtures like fly ash, GGBS, and silica fume may also be incorporated. In addition, site conditions such as transportation method, placing temperature, and early strength requirements should be considered before finalizing the mix. The final requirement is the test data of materials. Before trial mixing, laboratory tests must determine the specific gravity of cement and aggregates, water absorption, free surface moisture content, and sieve analysis of aggregates. These values are essential for accurate calculations and adjustments during batching. Finally, before starting the trial mix, always verify the complete checklist. Ensure that the concrete grade, cement type, aggregate size and grading, exposure condition, cement content, water cement ratio, workability, admixture details, and all material test data are available. Only then can the mix design process begin successfully as per IS 10262 2019. To conclude, a successful concrete mix design depends not only on calculations but also on the correct selection of materials and accurate laboratory test data. Careful attention to these parameters ensures that the concrete produced is strong, durable, workable, and economical. Thank you.